let's say we have our data here, and I'm just going to give us a few random sets of data to run through. An example might be, say we're changing angle and looking at energy, we might have that as our data. Let's say I've just made these points up. How would you say that data looks? What type of trend do you think we've got? Phil?
Linear.
Linear trend. Now again, if I draw a straight line, it's not going to go through all of those points. Why is that? Aiden? Yep, there are different intervals. Why else? In reality, when we recorded, that's pretty standard for how data could look, correct? Why does it look like that and not follow an exact line?
Because it's irregular data that we've gotten ourselves, and it's not like a 1-1 pattern.
Yeah?
It could be like errors.
Errors, okay? Errors is probably the main reason or uncertainties in what we're doing. Could be. Could be. Is it just errors? Is there other things that come into play? We're going to talk about gradient in a sec, but is there any other reason why the data may not exactly follow? That's likely an error because, again, it's all scattery. I'll break through first. We'll find a linear trend line. So if I was to, again, take a line of best fit through graphical, or one of our data logging, do we have to use the data logging process to find a linear trend? Can we all draw a line of best fit? An approximate line of best fit? And that line is of the form what? Yep, which is what? What's a linear equation? Y equals? mx plus c. Okay. Now, let's say my gradient here is, I've calculated my gradient, m equals 0.05. What does that mean? Let's say I'm dealing with angle down the bottom here, and my y-axis is velocity. What does that mean? What does the gradient of that line tell us about this process?
For every change in whatever angle, you get a 0.05 change in velocity.
Good. So for every angle degree that I improve, so every degree I increase, my velocity goes up 0.05 meters per second. What does the c tell me? C tells me, let's say this value here is 0.1. What's my c value say? What's it called? What is a c value called? Y-intercept. And what does that tell me?
Starting velocity.
My starting velocity. So what my velocity would be at my angle equals? 0. Okay. Can anyone think of an issue with my model right now?
There shouldn't be any velocity at 0 or at an angle of 0.
Does that make sense? Now, even though that's a line of best fit, and that probably works between our angle of, say, 30 and 180, does it work for all angles? Doesn't work below that. There's definitely an error in there. What about beyond 180? Do we know what's going to happen beyond 180? Why not?
Didn't test it.
Didn't test it. Is it possible to test a mousetrap beyond that angle?
Yeah.
How far can a mousetrap go? 180. Does that make sense? So that'd be talking about, if I was doing this modelling, I'd be talking about some of the limitations of my model. Let's look at a different model. Let's say my data didn't do that. And my data, go with a similar, we'll go with a similar style. Instead my data did this. Is that linear?
No.
Does that look linear? What type of model do you think we could have? Power, quadratic, something like that. Okay. Do I expect you to do this by hand? Could you draw a quadratic function and figure it out by hand?
No.
Not at your current state? No. So you would use graphical and you would get something that looks like this. And it will give you an A, a B and a C value. Again, the C value, let's not worry. I'm not going to worry about the A, B and C value here. All you need to do at this state in your mathematics is state that formula. What's the value of stating that formula? What does that tell us? What does that allow us to do?
It says you know the relations between the two.
Perfect. We have discrete data. What's discrete mean? Aiden?
Select.
It only works at a finite point, correct? We only know how this will work at the angle 180, 120, whatever we've got, whatever we've tested. This allows us to put a continuous function on it. So if I said to you, what will the velocity of your mousetrap racer be at the angle 137.6, could you figure it out using that?
Yes.
What would you do?
Substitute in what A, B, Z are.
And then let x equal 137.7 or whatever you want to find. Is that powerful? Relatively powerful? Okay, good. Let's go to the mass and force. Mass and force, I'll change these around. So again, what was our dependent variable for the one where we changed the mass? What's our dependent variable? Acceleration or mass? Acceleration. Well, and mass here. Now what was the general trend as mass increased? Acceleration went up or down? Down. A lot of us found that it looked something like this. Happy with that? What type of relationship have we got? Inverse. There are other relationships, but you won't know what they are yet. Now an inverse looks like y equals a over x. Now some people have chosen a power function where y equals ax to the p. Now do we know what our index laws? How do we get a over x? What's the power of that? Have we done much on index laws or negative indices? So the power that we need to get a over x is -1. When you put the power function in on your graphical, all you're saying is that p can be any number. So your power function will almost always fit more nicely, but it's a little bit harder to link to our theory. That's why I'm advising against it, unless you've got the last one that I'm about to show you. Happy with that?
So
Yep.
they're the same thing. So what's the difference between the inverse and power?
So a power doesn't always have to be 1. The power doesn't have to be 1. In a power function, it can be anything. Ella, you don't need to be writing on your iPad, for sure. All right. And the last type of function I'm going to show us, and this is where we are going to use our power function just because we're not quite at the capability where we can. It's probably more appropriate for angle and velocity. Something looks like that. And that, just going to give you the pointer. We're going to use a power, x to the p, where the p equals approximately a half. What that really means is y equals a times the square root of x. Are we happy with that? So the reason I've showed us all these different types of functions is what?
Help us link it to our.
Will help you firstly identify what type of theory, what type of graph do I have. So when I've gone through these 4, one of these should have rung a bell. At least one of these should have said, that's what my data looks like. You might have a couple that suit. What would you do if you had 2 types of models that suit your data? Talk about both. Talk about the strengths of one, the weaknesses of one, the strengths of the other, weaknesses of the other. Perfect. We clear with that? Nothing wrong with talking about 2 types of data in your function. Now, this is where the The ladies are sorted from the girls and the boys are sorted from the men. This is a rite of passage in science. Linking our model to theory. So what you need to think about is looking at your data, which we had over here before, looking at their data and thinking, why did my data do what it did? How did it go relative to what I expected? So if I've changed the angle of my mousetrap racer, what am I changing? What type of potential energy? Elastic. So I'm increasing elastic potential energy. So how does that affect velocity?
It's more elastic potential energy to be transferred into the kinetic energy.
So law of conservation of energy says I should have more kinetic energy. Correct? So if I increase my kinetic energy, so I double my elastic potential, I therefore should double my kinetic energy, shouldn't I? Which means I should see what in my velocity? Well, I don't know. You need to think about the equations. So you've got two equations. KE equals half mv squared and F equals ma. Now, depending on which pathway you've chosen, you'll have to use those equations. And you'll need to ask yourself, if everything's kept constant except for two variables, as one goes up, how will that impact the other? A B student or a C student says kinetic energy went up, velocity went up. An A student says kinetic energy doubled, how did that impact my velocity? For force and mass, you need to think about what do we keep constant, what do we change, and what impact should that have? If you're setting your mousetrap to the same spot every time, you should be able to definitively say something about your force. It's about linking what you've got in your data to your theory. Now let's say your data doesn't perfectly match your theory. That's fine. I expect that your data won't match your theory. Why? Errors, there's other things as well, not just errors. What happens? The law of conservation of energy. So we're doubling our angle, therefore we're doubling our kinetic energy. Is that a pretty sound statement? Could I write that in a scientific journal? I doubled my angle, therefore I doubled my kinetic energy. I can't just say that, can I? Does energy, the law of conservation of energy, mean if you drop a ball from a height, it's going to return to the exact same height?
Because it expends energy elsewhere.
Does that make sense? So you should see changes in your data. F equals ma, that's all well and good. You need to think about factors of friction. You need to think about how did your mousetrap go. I've seen plenty of data. I'll come over here. I've seen plenty of data that looks like this. At low masses it increases and then it goes back down. There's perfectly good reason for that. I'm not going to tell you what it is, but there are reasons for that. Good students talk about, yes, my data disagrees. They obviously wouldn't say my because they don't want to use personal language in an experiment. But they'd say, yes, the data disagrees with the theory. However, this is because of, or this is likely because of this. Are we clear on what needs to be done? It's being critical about what's going on in our data. It's about saying, this is what my data says should have occurred. My data generally follows this, however, it doesn't exactly. Why is that the case? If it completely refutes your data, why is that the case? Why do you think my data... I've got a linear trend, but I'm supposed to see an exponential trend. Why is that? And if you're doing that well, it doesn't really matter what your data says. As long as you're being critical and justifying your claims. Clear? Good luck.